Now, let's take a look at an example problem called pivot index. This problem statement is that given an array of integers called nums, write a method that returns the quote-unquote pivot index of this array. Here we define the pivot index as the index where the sum of all the numbers to the left of the index is equal to the sum of all the numbers to the right of the index. And if no such index exists, we should return -1. Now, let's take a look at example input 1. Here we have an array called nums that contains the value 2, 6, 1, 2, 4, 5. For this example input, our output for the pivot index will be the third index. And this is because the sum of the numbers that are left of the third index, which are 2, 6, and 1, they all add up to 9, and that is equal to the sum of the numbers right of the third index, which are the values 4 and 5, and once again, they also add up to the value of 9. And now let's take a look at example input 2. Here we have an array called nums that contains the value 1, 2, and 3. Here our output for the pivot index will be -1. And this is because there is no index that satisfies the conditions in the problem statement. Now, we will solve this problem by following the technical question approach that we have covered in the previous section. The step 1 is to ask questions. And the question we ask here is, what happens if the input contains multiple pivot indexes? Is it possible to return the leftmost index? Or is it necessary to return all pivot indexes? This is something that will be really helpful to clarify with your interviewer. Step 2 is to design an algorithm. And here we want to start off by asking, what is the brute force solution here? Here, the brute force solution is that we can assume the input array has size n. And we can iterate through each index and compute the left sum, which is sum of elements to its left, and the right sum, which is the sum of elements to its right. And then we check if the left sum and the right sum equals each other. And if it does, we return that index. And if none of the sum pairs equal each other, then we return -1. And for this brute force solution, we also want to know what is the time complexity is. In the worst case, each sum operation takes O of n, and this is done n times. So this actually gives this brute force solution the runtime of O of n squared. Now that we have established a brute force solution, we want to ask ourselves, okay, so what would be a more efficient solution? You can ask, is there a way to do this with a single pass or loop? And is there any relationship between the sum of numbers left of the pivot index and the sum of numbers right of the pivot index that we can utilize to help us answer this question more efficiently? And once we ask these kind of questions, hopefully we can also come up with this efficient solution. An efficient solution for this problem is that we need to compute the sum of values to the left and the right of every index. And assume total sum as the sum of all numbers. If we knew the sum of numbers that are left of index I, which we will call left sum, and the other sum to the right of index, which we will call right sum, then the relationship between the two would be right sum is equal to total sum minus left sum minus number at that index I. We only need to know the total sum, left sum, and value the current index to check whether the current index is a pivot index in constant time. And then what we do here is that we iterate through candidate indexes of I and maintain the value of the left sum. And here's what the solution will look like. First, we get the total sums, which will take O of n time. And then we'll declare left sum, which is initialized with value of 0, and it will keep the tab. We'll go through each element in the nums input, and then we check if the left sum is equal to total sum minus left sum minus the value at the current index, which we'll call x, they're equal to each other, then we have found the pivot index and return that index I. If not, then we will increment the left sums by adding the current value to the left sum. And it will do this until we have either found the pivot index or we have not found the pivot index, in which case we will return -1 at the end. To get more practices on these array problems, here's a list of practice problems that you can check out. You can find the links to these problems in the video description, as well as the slide attachment that is also attached to this video.